Guys, welcome to another episode of CCT. So today we're going to be going over this one, linked list cycle 2. I have looked at the answer, or at least the algorithm for it. This is similar to the linked list cycle 1, but you need to understand it a lot more in order to actually solve linked list cycle 2. If you guys will remember, I think I did have a video about linked list cycle 1. I may have called it that or Floyd cycle detection algorithm. And I think I'll go over that quickly, the Floyd cycle detection, and then we'll get to this question, which is figuring out not only if there's a cycle in a linked list, which is what the first one was asking, but where is the start of the list? Okay? Yeah, and through this video I will be proving everything with math. Okay, so this will be a solid explanation, and if the intuition doesn't satisfy you, the math will. Okay, so let's get into it. Also, I'm on this free trial for the Mischief Pro, and it allows me to do this, which I'm so happy about. Finally, I get to use multiple colors. So let's use this color. Let's get a blue in here. And let's get, yeah, okay. So we'll use this as our main color. So let's first go over how you detect if there is a cycle. So the Floyd cycle algorithm is that you go through the list with a fast iterator, which goes two steps at a time, and a slow iterator, which goes one. And if they ever meet, then you know there is a cycle. If the fast gets to like the end or the null at some point, then you know that it didn't have a cycle. But what's going to be important this time is where they meet. We'll go over that a bit later, but let me just show you quickly what this looks like. So I'll use green. Now let's use blue for fast. So fast is going to take 2 steps, and slow takes 1 step. Then fast takes another 2 steps. Slow takes 1 step. Fast takes 1. Let's do it like this. 1, 2 steps. And slow takes 1 step. So this is where fast and slow meet after 3 iterations after 3. And now we know that there's a cycle. Some intuition. So when I first went through this, I thought, well, how is it really guaranteed that they'll intersect? Like, I could see that it's possible because fast would just like go around the loop faster than the slow, but like, isn't it possible if the fast just like always jumps over the slow? Well, let's build some intuition. Let's have some cases. So let's say we have something like this, where the fast one is here, and the slow one is here. Then that means on the next iteration, they will meet here, right? Okay, so this case, when fast is right behind slow at some point, it checks out that they'll meet with each other. It's like, okay, fine. But that's not the only case, right? We could have the fast be here, and then like one in the middle, and have the slow be there. Fast. But then, after one iteration, fast goes here, and slow goes here. And then we have exactly the same cases here. And what you could see with intuition is it's kind of like every iteration, the fast one creeps up on the slow one by 1. It's actually, the fast one just can't skip over the slow one. It's impossible. Because the only way for it to skip over it is if they are like both, if they are like both in the same squares node at one point, and then fast goes over 2, and then slow goes here. That's the only way, but then, hello, they intersected here. So they have to intersect. That's some intuition money. This is called the Floyd cycle detection algorithm, or like the hare and the tortoise algorithm, I think it might be referred to, because it's like the fast is like the hare, the slow is the tortoise. But where exactly is this happening? I want to know, can we predict the exact point that it's happening at? Well, what if we, let's say that let's put some variables at this. Let's say the amount of nodes before the start of the cycle is k, and then the cycle itself is c, so cycle equals c, or cycle nodes equals c. And then let's let x equal position, or not position. Let's call it moves, or iteration. Okay, yeah, let's call it iteration. Iterations after slow iterator has gotten to start of cycle. So it's like the iterations after. And what we're trying to figure out in this is like which position in the cycle do they meet, assuming that there is a cycle. Which position in the cycle do they meet? Let's see. Is there a good way to do this? Could I copy this graph? So this is, again, a little new. I have the toolbar. Let's just see quickly. Is there a copy thing here? This is, let me use the mouse for a second. Mouse is, there it is. What does this do? So if I've never done this before. Let's see what happens. If I do that, and I press Command C, could I paste it? Ooh, I can't. Wait, hold on. Let's try to go here. Beautiful. Oh, I did not know I could do that. This is the pro version. I think I'll probably buy it. This is just the free trial, like I said before. Great. So that's good. Brush. Oh, I have to go back to user. Yeah. Oh, it's not brush. Okay. Let's erase that. So now we could represent it as like x equals, one second, I want it to be this. Okay, even though they look the same. So x, when x equals 2x plus k, I'll go over this, don't worry, over c. So what we're trying to figure out, which node in this cycle, which is x, that the hare and the tortoise will intersect. So it would be when x, which is the iterations going forward once he goes here, plus this is like k. Okay, I told you k was here, this the amount before the cycle, but k could also be considered as the starting position of the hare. So this is like start position of hare. I don't know how you spell hare. I think it's R-E actually. Hare when the tortoise gets to here. Why is it k? Well, you might think it's like 2k because by the time that the tortoise got to here, the hare would have had time to go double the distance, right? Look, it goes like 4k by the time the hare goes here. But this is how far it is from the start of the cycle. So k, remember, k is the starting position of the hare. So that means like this is also k. How else? Let me rephrase this. So if the tortoise is going here, moved 2 iterations, that means hare would get to here. And that is representative of how it's the hare's head start from being in the cycle, the hare's starting position of the cycle. And we know it's k because this distance is k, and the hare went double, so it did move 2k positions by the time the tortoise got to here. It did move 2k positions, but it only moved k positions in the cycle. So move 2, so by, okay, let me write this note out. So note, by this time, hare has moved 2k nodes, aka k nodes from start of cycle. Hopefully that makes sense. The hare has moved 2k in total because the tortoise moved k, so the hare moved 2k, but only k from the start, because this is k. Yeah, okay, that makes sense. And just try to think about that a bit, like I just did, if that doesn't make sense yet. Okay, how do you solve this? Well, you could just do basic arithmetic. By the way, this means equals under mod C. So you could subtract the 2x. Well, I'll subtract this side. So that's going to be just x equals negative k under mod C. Okay, so we found the position in the cycle that the tortoise and the hare are going to intersect. And it's specifically at negative k. So what does negative k mean? So that means x equals, in this case, negative k would be negative 2 mod 3, right? And what does that equal? Who knows what negative 2 mod 3 is? So it's kind of like going in reverse the the cycle. So negative 2 mod 3 is positive 1 mod 3. I should put these at 0, 1, 2. So it did get the position correct. It's right there. So this is where tortoise and hare will meet. Guaranteed. I do not know how to spell guaranteed, but this is just proving that's where they'll meet. So if this is where they'll meet here. The question for, finally back to the question, is how to figure out the exact position of the start of this start. Well, now it's a little easier to see that, let me see if I can paste this thing again. Yeah. Yeah, it's a little easier to see that what if we just, like, after we find this starting point, we know it's negative k, so that means it's, let me do another color. Let's do, like, oh, I already have it. That's like 1, 2 in that direction. If we wanted to figure out where this is, like, okay, again, we don't actually know the size of k right now, but we do know if we go the same amount here, like 1, if we have an iterator going from here, 1, 2, and we have an iterator from here, the intersection going 1, 2, we know they'll meet at the starting position because this started negative k values or nodes from the starting position, and we know this started, well, I guess you could also say negative k nodes from the starting position. So we know we could just find when they intersect each other. So because this node, negative k position from start. Here is all the start is also negative k position from start by definition. This is by solving, we found that to be true. So then we could just have the iterator go through that. Okay, let's code this out. So let's do air equals list node pointer air is going to point to head list node. I actually like to keep the pointers on that side. This is going to point to tort twice. Is also going to start at head, so they're both starting at head. Then what we want to do, so is it guaranteed that there's no, it's not guaranteed that there's a cycle. So while hair does not equal null, I guess. I forget how you write this, is it like that? While hair does not equal null, so if it does equal null, then yeah, then we have to just return null. There's no pointer. Okay, so hair. Oh yeah, and then we should also write list code intersection. Hair. So if hair equals. I don't. Are you supposed to dereference? Wait, are we seeing if the pointers are equal? I honestly forget if this sees if the what they're pointing to is equal. Probably does, but I might have to check the answers for that. Or I might consult the internet. Okay, whatever. Just let's get the idea down. So if they equal set intersection to be paired. Oh, you know what we could do? Wait a while. No, we can just do it here. I don't care. So equals pair or whatever, and then break. And then we also should check if, or that's it. Yeah. So if by this time hair equals null, we should just return null. I don't know if this is how you do it. Null. Else, then we're going to start from the head again. And so we're going to start from the intersection and head. So while, oh, we never updated the hair, so hair gets hair next. Well, I could already see a problem with that one because it's going to next, so we can't. What if it's if hair next doesn't equal null? And then something like that. I don't know. We'll go over that. So then hair and tortoise gets hair. No, gets tortoise next. Right, it's moving one at a time. So if it does equal, if the next equals null, then we should, yeah, that does protect it. There's no way tortoise can equal null before hair because hair is moving way faster. So, yeah, this protect. Oh, it's if, wait, if that equals null or hair, wait, and, sorry, hair does not equal. Okay, right. So then while, now we could just say now, while true, really, because we know that there's a cycle at this point. So if intersection equals head, return either, it doesn't matter. So else we're just going to say intersection gets intersection next. Remember, now we're going one at a time for both of them because we know they're going to eventually hit each other because they're both equal to like negative k values from the starting position. Okay. Yeah. I will try to run this. Oh yeah, I forgot to the edge case if tail connects to the index 1. So it's this one and it connects at, so I outputted 0. So I did get this far, but well, first I just want to, well, if they always like to throw this edge case, so it's always good to do this equals null, return null. This one, I want to see how many. So intersection was set. Tail connects to node at index 0. I want to see how many times it goes through. Cout, racing, cout, intersection. I just want to see how many times each one of these goes through. So racing went through once and intersection went through once. Is that correct? I don't think so. No, it's definitely not correct. I don't, oh, it's because they equal each other right now. Yeah, at the beginning, yeah. So really, where we could start this is like more like, no, wait, I want to make sure I have those safety checks. If it's one node and it's looped within itself, let me do this. If head next equals null, this means it's like a one node list, then I think I could return the, oh, yeah, also return null, because it's not connected anywhere. Now I have the freedom to do here gets next, and tortoise gets next. This is kind of like their starting position. Okay, let's see if that works better. Because before they were starting off at the same place. Okay, good. Yeah, that worked. What about, I'm just curious, well, my edge cases should work because when it's null, returns null. And, okay, yeah, we could try to submit this. It looks pretty good to me. I don't know if they'll appreciate these CIs. I forget if they do. Wait, runtime error number access within. Yeah, I have no idea what that means. But I will. What is the. While member access within. Oh. member access within null pointer struct was node. I have like no idea what that means. But this is the last executed input. Let's just see what, like, why is there a negative? Why do they want a negative position? That's so weird. Okay, I'm gonna go to my solution that I got last time, or quickly, let me see if I can figure this out. So I have this, I have that, I have that, I have if slow equals fast break, slow is dead, and then they, yeah, I do this again. The only thing that's, whatever. I'll just put this one in because I did this one before, and you'll see it works. It's basically the same thing. If you guys see the error here, feel free to let me know. But I want to end this video, so run this, and it's the same idea. It's probably just something small. All right, thanks for watching, everybody. Hopefully you learned something and learned as I was struggling, because that is the best way to learn. You see me do mistakes, and you see my thought process when it's organic and slow versus scripted. Okay, have a good day. See ya.